In the last session, we saw some key concepts of machine learning like supervised learning and unsupervised learning. We will continue with the key concepts of machine learning this session. Uh, we have other techniques of machine learning like semi-supervised and reinforcement learning we'll be discussing now. So let's begin. So as I told you already, there are four types of machine learning techniques, supervised and unsupervised. And there are other two called as semi-supervised and reinforcement learning. So as the word itself says, semi-supervised means it is a combination of supervised and unsupervised. Now, if you're typically using a supervised learning method, you will be having labeled data. If you are using an unsupervised method, you'll be having data which is not labeled. You'll be having unlabeled data. Now, now you may have a data set where you may have a combination of labeled data and unlabeled data, or it is also possible that labeling the data, if you try to label the data, it will be very time consuming and can become a very costly process. So in such cases you can go for semi supervised learning. Since here in this case you can have labeled data as well as unlabeled data, and a very good example of semi supervised learning is Google Photos, where you just add one label to a person and it is able to automatically name in every photo that person. Of course, sometimes there can be kind of mistakes where a person may look similar, then it may name it wrongly, but that's very rare, right? So Google Photos is a very good example of semi supervised learning. And here, since it is a combination of supervised and unsupervised learning method, for unsupervised, in some cases, it may be using clustering algorithm, which we discussed in the last session. So for example, let's take this figure. Right here, there are two classes. Let's say these are the data sets. And we have to classify the data sets. Either it belongs to triangle or it has to belong to square. So this is a two-class problem. So this data set is having some labeled data. The labeled data are the triangle and the other one is a square. And there are a lot of unlabeled data, that is these circles. Okay, so this is our total training data set that we are giving for training. Okay, so we have labeled data as well as unlabeled data. Now the problem is I have to predict what is the class of this cross mark. Okay, so what is the class of this cross mark? Either it has to belong to a triangle or it has to belong to a square. So if suppose it is using clustering algorithm, then it may try to group similar instances together. So probably this is one cluster, this is another cluster, and this is another cluster. So that means in this cluster, all the circles here will be treated as triangle. If this is a cluster, all the blue circles here will be treated as a square. So probably this cross can also be treated as a square. So that is like that is when you are using a clustering based algorithm for predicting the class of this cross. So this is the block diagram of a semi-supervised learning. This is our model, and we have different kinds of inputs which we are giving to our model. I'll be giving some unlabeled data. I'm giving some partially labeled data. I'm also giving some unlabeled data. Right? So you can see here, this is a completely unlabeled data. I have your elephant, turtle, and dog. Completely, I have not given the label. I have just given the data sets. You have a partial labeled here. I have the elephant labeled as elephant. Okay, this is a snake. I have the snake which is labeled as a snake. And I have some data sets here which I'm completely giving it to the model without giving any labels. So that is semi-supervised learning, where you can have unlabeled data, partially labeled data. You can also have unlabeled data in your data sets. And finally, the result is the same. You have to do a prediction, right? Maybe you have to, it has to predict as a dog, a snake, or a dog, or an elephant. So that is semi-supervised learning. So coming to the fourth type of machine learning algorithm, reinforcement learning. So in simple words, to understand reinforcement learning, here the learning is very similar to how we actually try to teach a kid, right? So suppose a child doesn't wants to learn, we have to motivate the child to learn. And how do we motivate the child? By reinforcing learning. We reinforce learning into the child by either giving rewards. So you say to the child, if you learn this, I'm going to give you this reward in return. Or sometimes it can be a penalty where you kind of give some kind of small punishment if the child is not studying. So that is called as reinforcemental learning, right? So the same thing is also applied here in machine learning, where the learning system will learn based upon some policies, and the based upon the action performed by the learning system, the model will either get a reward in return or a penalty in return. So if you see this diagram, the learning system in a reinforcement learning is called as an agent. So the agent will observe the environment and it learns and performs certain actions. Now, if its action is correct, it will be given a reward. If the action is wrong, it will be given a penalty. So if you see this diagram here, and the action will learn based upon some strategy, right? The agent will learn based upon a certain strategy. That strategy is called as a policy. Okay, so these are the key words of reinforcement learning: agent, policy, rewards, penalties. So agent is a learning system, policy is the learning strategy, and the result of learning is either a reward if it is a correct learning, penalty if it was a wrong learning. So if you see this diagram, agent here, right, it is learning from the environment. Suppose it's going towards a fire, right, you are giving it a penalty of minus 50 points. Suppose it's going next, so next time what happens when it gets the penalty, it will avoid it, right? So it will update its policy. So when it gets a penalty, it will update its policy in the next learning step. So basically it will iterate, right? The learning will be an iteration process until an optimal policy is found. A very good example of reinforcement learning is robots, right? The robots implement reinforcement learning to learn how to walk. So when a robot is walking, suppose it's coming to an obstacle, it falls. So that would be a penalty. It learns, and therefore next time it tries to avoid that. So robots implement reinforcement learning. And another very good example is DeepMind's AlphaGo program, right? It's a very good example of reinforcement learning, where it made headlines in the May 2017 when it actually bet the champion in the game of Go. So here it learned, right? The algorithm was allowed to learn, right, the policies, and it was made to learn millions of games, and anytime it was making mistakes, it was given penalties and it was updating its policy. So the algorithm was allowed to learn many times, and finally during a competition, the learning was actually turned off. And then the AlphaGo was just applying the policy it had learned previously during its learning phase. So it's like learning and then taking the exam. So when it's taking the exam, the learning would be turned off. That is reinforcement learning. And there's one more under unsupervised learning, there's another kind of very popularly used learning method called as association rule learning. In association rule learning, we can it's very understand through a supermarket analysis. It's an ultimate guide. You can use association rule analysis for supermarket analysis. Suppose let's say you see the sales logs, and looking at the sales of the supermarket, you can understand that people who are purchasing sauce are also purchasing chips, potato chips. Okay, if you look at the sales log, suppose this is the what it reveals, right? So normally what we do is the markets people do is they try to place these two items close to one another, right? The similar concept is used in association rule learning, where the goal is to dig into these large amounts of data and try to understand the relationship between the attributes of the data. Okay, so association rule learning is about digging into large amounts of data and trying to understand interesting relationship between the attributes of the data. And two very popular algorithms of association rule learning is eclat and a priori. So this is another very famously used learning method called as transfer learning. As the word itself says, you're transferring the knowledge, right? So here there is a transfer of knowledge, and this is very popularly used especially in deep neural networks. Deep neural networks are neural networks which is composed of many layers of neurons. Now to simply understand this, let's look into this diagram. See, as we already saw, let's say a supervised learning. What happens in supervised learning? You give label data and the model is learning from the label data. And finally, after the learning process is over, you either classify the data as dog or some other object. Now here what happens in a typical supervised learning is you have to train the model on the data sets, right? Huge amount of data sets. Therefore, a lot of time is consumed for training, and it also consumes a lot of computational cost, like requires a lot of hardware. So to overcome that problem, we have transfer learning where the training process is made easier by giving pre-trained models, right? Pre-trained models are given, and therefore the training process is made easier. So by using these pre-trained models, already these pre-trained models would have already been trained using this large data sets, and therefore making the training task easier. Now under transfer learning also various types are there, like transductive learning where the target task and the source task are same but they use different data sets. Inductive transfer, where the source task in a sense problem, and the target problem are different regardless of the data set. Unsupervised transfer, where both source problem as well as the target problem is different, but the process uses unlabeled source and target data. You also have other classifications of transfer learning like positive transfer learning, negative, neutral transfers learning, and there's also something called as near transfer learning and far transfer learning. Now these things are you can learn when you get into try to implement your work using transfer learning. Then you have to go through all these different types and try to work on that. But it's a very good projects you can do using transfer learning. And the advantage of this is as already you have a pre-trained model, so definitely you need very less data, very versatile because already you have a very good pre-trained model which is proven to be good, right? The pre-trained model is proven to be good, which will definitely have good performance, right? So therefore you have improved performance, speeds up, and also it prevents overfitting and reduce computational cost. Now what is overfitting, underfitting, we'll see it later. Now, there's one more very important concept that you need to learn before we start implementing any of your projects called as dimensionality reduction. Now, this is not a learning strategy. This is not a learning method. It is you can say it's like a pre-processing. See, when you're doing your projects, you're taking huge data sets into your work, right? So trying to making the model learn so much of data which can be in lakhs, sometimes 10,000, 20,000 lakhs, then definitely it can be very time consuming, and also very you need to have very good computational resources, hardware systems in order to run these kinds of data sets in your systems, right? So to simplify this work, we do dimensionality reduction, where basically you are trying to reduce the dimensions of your training data, but ensuring that you don't lose too much information. And also here feature extraction and so many other different concepts comes into picture. Feature extraction, dimensionality reduction, these are all important pre-processing steps that we need to do before doing the before training your model, right? So basically the advantage of dimensionality reduction is it will run much faster, right? Because now you have reduced the dimensions of your training data, definitely the speed will improve, and also it will take up less disk space and memory space, and therefore you get good performance. So note that it's often a good idea to reduce the number of dimensions in your training data using the dimensionality reduction algorithm before you feed it to a machine learning algorithm. So it's like a pre-processing step that is very commonly used in machine learning. So let's take some case studies also. So normally there's something called as anomaly detection. So just take to simply understand, if suppose I'm using unsupervised learning. Okay, now these are the data sets I have. As I told you, in unsupervised learning, you will not have labels to your data sets, right? There are no labels. So how does it identify, right? We discussed that in the last session. You can have different strategies, you have different algorithms under unsupervised. Let's say you're using clustering, right? Uh, so what happens in clustering is it is trying to make clusters, right, of in your data sets based upon some kind of similarities. Now, if you see this data set, there is one data set which is here and there's another data set here, right? You're trying to predict. Suppose I'm trying to predict what is the class of this red data set, and what is the class of this red data set, green data set. So looking at this, Like if it is doing clustering analysis where it making clusters based upon the similarities, it may say that this crossmark, green crossmark, is normal because it is among these other data sets. And looking at that, this red one, it may say that this can be an anomaly, right, since it is away from the other data sets. So especially in credit card transactions, suppose you're trying to detect some kind of fraud transactions in a credit card, you will have suppose 1,000 credit card transactions, right, which are all noted down here, and you can see that most of the transactions are lying here and only one transaction is somewhere here. So the algorithm will automatically say that this is an anomaly, right, that can be some kind of a fraud here because the activity looks very different from the rest, right? You might have come across such things when you are using suppose uh, Kindle also, right? Sometimes you do some kind of activity when you're using your ebook and you lose the access. Probably it might be because of this. Any action that you might have done while accessing your ebook, right? It might have thought that that action is very different from the rest of the other actions, and therefore saying that it's an anomaly or it may be a fraud, and it is trying to block you from using the book. Now that may be right sometimes, but sometimes it may be a wrong detection. So in such cases, it's good to go for novelty detection. Now what happens in novelty detection is, see this example. Let's say I have images of all the different dog breeds, right? And I'm supposed to identify the dog breed. Now Chihuahua is also one kind of a dog. Now when you are using unsupervised learning where I did not give labels, so the algorithm may feel that all these dog breeds look similar, but Chihuahua maybe it's a little bit different and it's a very rare dog. It may feel that this dog looks different from the rest, and therefore it may say that the algorithm may say that this is not a dog because its characteristics may look different from the rest. Now saying that it's not a dog is a wrong prediction, right? So in such cases, it's better to go for novelty detection where you aim to detect new instances. The aim here is to detect new instances that look different from all the instances in the training set. So novelty detection is, the goal is to detect new instances. Okay, but an important prerequisite here is you should have a clean training set. So if you're looking for projects, you can also work on this, like novelty detection for dog detection and Chihuahua detection. It's a very common case study that you can work on this. You can do a project on this, mini project on this, novelty detection methods for identification of Chihuahuas in dog breeds. Okay, so this is one case study. You can also do a project on this anomaly detection of unusual credit card transaction. That is also one kind of project that you can do. Now coming to two more kinds of learning, batch learning and online learning. Now batch learning is about, now we have seen different methods of learning. Now the next question is I have some, let's say 90,000 data sets, 90,000 images you have. Now, are you going to give all the 90,000 images directly to your algorithm to train? Now, that doesn't make sense, right? You're giving 90,000 images, even after doing dimensionality reduction, can be very computationally very extensive method, right? It can be very difficult to train. So then you have to decide how I'm going to give the data sets for training. So one is batch learning. In batch learning, what happens here is, here, if you see this diagram here, right, this is more like the system is incapable of learning suppose the system is incapable of learning incrementally, right? Then you just give the data sets to the system, right? And the system is first trained and then you launch into production, and suppose there is a problem, again you have to come back. So normally it's a very iterative process. Training is not just in one go. Okay, training doesn't happen in one go. You train the system on some data, and suppose there is a problem, you come back again, you train. So training always doesn't happen in one go, you keep doing, right? So first the system is trained, then we launch it into production. So training will happen recursively, iteratively, many times, and then we put it into production. That's why we call it as also offline training, right? So there is a disadvantage here, right? So if you go for batch learning, also called as offline learning, the problem is you are using full set of data. right? In batch learning, we are completely giving full set of data. Now, completely giving such huge data will take many hours and may even take many weeks for training, and lot of computing resources it needs, right? So the solution for batch learning is incremental learning. Okay, so in incremental learning, what happens is we are trying to give the data in batches. We don't give the entire 90,000 images in one go. We make batches, small groups, and we call it as mini batches, right? And each learning step, and therefore what happens, since we give mini batches, the learning step will be very fast and cheap. Okay, and we also call, that's why we also call it as online training. But do not confuse, this is not like I'm going to train it on a live system. It's that is why it's also called as incremental learning, because you go on, you make the system to learn incrementally. First you give a first batch, and then you give the second batch, and then you give the third batch. So incrementally you are giving data to the system to learn, and then after learning you again evaluate, right? And if everything is fine, then you give the next batch. So therefore what happens, this process will need limited computing resources, right? And it will require less memory also, right? Because you are splitting up the huge data sets into many different pieces or small chunks of data sets. It will need less memory in the system. And also that's why this is called as online learning, but this is actually done offline. We don't do it on the live system. So it's also, that is why also called as incremental learning. See, this second diagram actually shows that how online learning or incrementally learning is handling huge data sets. So you have here the huge data sets. You are going to, lots of data is there, you chop it into pieces. This is a huge data set, you make it into various pieces, and then you give for training. You train it, you evaluate any errors, again study the problem, again train, again evaluate, until you are fine with the evaluation in the sense we will check for the performance. Until we are satisfied with the performance, we keep evaluating, we keep analyzing the errors, we keep training the model. So once you are fine with the evaluation, then you launch the product. So that is incremental learning. So advantages is, as we are making it to chunks of data, we are making it to small chunks of data. The learning rate is very good, right? That means it's learning fast and adapting to the changing data. Now, learning rate is also a very important concept when you're doing projects. You can set your learning rate high, you can set it low. High learning rate means you're learning fast, and therefore you also tend to quickly forget the old data. If it's a low learning rate, the system will have more inertia, it will learn more slowly. But the challenges with online learning is, if there is a bad data in the system, right, then the system performance will gradually decline. First time I'm giving small chunk of data, and probably there's a bad data in it, the performance will go down. And if you are now talking about live system, the clients will notice this. So that can be a problem. So in order to reduce that risk of underperformance, you need to monitor your system closely. And suppose you feel that performance went down, then you have to switch off the learning system light and check what was the problem with the data set. So these are some of the things that you will learn while you're doing your project. So basically, to summarize, in today's session and in the previous sessions, so far we have just tried to cover the basic groundwork which is necessary to implement a simple project, right? So in the next session, we will do our first hands-on project where we will train and run a linear model using scikit-learn, and we will also work using KNN classifiers. So thank you so much. Let's meet in the next session where we will work on this first end-to-end machine learning project. Thank you so much.